China just dropped something nobody expected, and honestly, the robotics world is still trying to understand what this means. Trust Robotics just showed the world's first humanoid robot that can do hand embroidery live, threading a needle and stitching a logo with both hands at sub-millimeter accuracy. And here is the crazy part. This company started less than 11 months ago, in February 2025, and already raised $242 million in funding. Let me explain why this matters and why every robotics person should be paying attention right now. Here is the thing. When you watch a human thread a needle and saw, it looks simple. But for robotics, this has been called impossible to automate for decades. We're talking about a task that needs your hands to work together perfectly, feel the tiniest movements, adjust pressure instantly, and handle soft, floppy materials that change shape constantly. On December 22, Cross worked onto a stage and did it live. No tricks, no pre-program movements, just a robot using both hands to thread a noodle smaller than a few millimeters wide, grab fixable thread and cloth, and stitch their logo cleanly. The robot hit sub-millimeter precision throughout the entire task, which means it stayed accurate down to less than 1 millimeter at every step. And honestly, when you see the demo footage, it looks smooth. The movements don't feel robotic or jerky. They look controlled, careful, almost human. Now, let's talk about why hand embroidery is actually a huge deal. The robotics industry has a nickname for ultra-fine fixable handling tasks like this. Engineers call wire harness assembly, which is similar, the gold badge conjecture of robotics. That's a reference to one of the hardest unsolved problems in math. Why? Because you need three things happening at once. First, sub-millimeter visual tracking to see exactly where tiny objects are. Second, adaptive focus control, meaning the robot has to feel how hard it's pushing and adjust instantly so it doesn't rip the thread or damage the fabric. And third, coordinated bimanual manipulation. That's a fancy way of saying both hands working together at the same time, doing different jobs while keeping perfect timing. Most robots can do one of these things. Some advanced robots can do two. But doing all three at once with soft materials that move and shift, that was the wall nobody could break through until now. What makes this even more interesting is what this breakthrough means for manufacturing. Tross didn't do this demo just to show off embroidery skills. They are proving their robot can handle any task with similar requirements. Wire harness assembly in cars and planes has been stuck in human hands for decades because robots couldn't manage the floppy cables, the tiny connectors, and the tight spaces. Now, TARS is saying they solved it. They claim their Humanoid is the first robotics company to crack the wire harness manufacturing problem that's frustrated automotive and aerospace makers for years. And if that's true, we're looking at a total shift in how factories operate. Tasks that needed skilled human workers could now move to robots that work 24 hours a day without getting tired or making mistakes from tiredness. The first piece of how this works is the data AI physics trinity. That's what CEO Dr. Chen Yelun calls it. Chen used to be the CTO and chief scientist of the autonomous driving system at Huawei's Intelligent Automotive Solution Business Unit, which is Huawei's car division. Before that, he was the chief machine vision engineer at DJI, the drone company. So this guy knows how to build AI systems that interact with the physical world. The Trinity approach connects three parts into one loop. First, real-world data collection through their sensor platform. This system watches humans doing tasks and captures detailed information about how they move, how much force they use, what they look at, and how they adjust when something goes wrong. Second, AI training using their AWE 2.0 model, which stands for AI World Engine. This model learns general physical skills, not single tasks. That's important. Most robots get trained for one job and fail when you change the environment. AWE 2.0 learns how to adapt. And third, physical execution on their T-series and A-series humanoid robots. These robots are built with what they call a minimal digital to physical gap, meaning what the AI learns in training actually works in the real world without breaking down. The second phase is the hardware design itself. TAR says every component in their robots is self-developed. The hands use 5-figured and effectors with real-time tactile and force feedback. That means the robot constantly feels what it's touching and adjusts pressure instantly. The actuators, which are the motors that move the joints, are custom built to minimize vibrations. This matters because even tiny 6-Reuben precision weight you are working at sub-millimeter scale. The robots also have hybrid position and force control, which lets them hold something in place while also applying the exact right amount of push or pull. For embroidering, that means one hand holds the fabric steadily while other hand pushes the needle through without tearing anything. Trust showed 2 robot models in December. The A series is for industrial use and can have wheels or work stationary. The D series is the general purpose humanoid that works on 2 links. Both share the same AI brain and skilled hands but have different lower bodies depending on the job. Now, here is where it gets interesting. The company didn't just build a robot that can do one task really well. They built a system that generalizes. Dr. Deng Wingchao, the chief scientist at TARS, explained this clearly. Deng is a former Huawei Genius Youth, which is Huawei's Elite Talent Program, and he is currently a tenure-track associate professor at Fudan University's Academy for Engineering and Technology. He received his PhD from Hong Kong University of Science and Technology in 2020 and worked at Huawei from 2020 to 2023, helping build their self-driving car system. He said they had seen a huge jump in task success rates across multiple different situations because of the massive data from sensors combined with the AWE 2.0 model. And he pointed out that as they keep scaling the data and improving the model, the robots will get smarter and more adaptable. The goal isn't to make a robot that only does embroidery. The goal is to make robots that can learn any physical task and apply that knowledge to new environments they have never seen before. In one example, TARS showed their robot handling wire harness assembly. Wire harnesses are bundles of cables that need to be routed through tight spaces, bent around corners, and plugged into tiny connectors. The cables are floppy, the connectors are dense, and it's easy to sag or damage something. In the demo footage, the robot grabbed loose wires, handled them smoothly, and inserted them into connector ports without jamming or breaking anything. Again, this is something humans do thousands of times per day in factories, but robots have failed at for decades. And honestly, watching the robot do it, the movements look natural. There is no hesitation, no failed attempts. It just works. To be clear, this technology isn't perfect yet. TARS hasn't released full benchmark comparisons or failure rate data. We don't know how often the robot makes mistakes over long production runs. We also don't know how well it handles extreme edge cases like torn fabric, tangled thread, or damaged materials. And the company has only shown control demos so far, not months of continuous factory deployment. But even with those gaps, what they have demonstrated publicly is already beyond what most robotics companies have achieved. The fact that they can do it live in front of an audience without pre-scripted motions shows they have built something real. Now, let's talk about the funding, because that tells you how seriously investors are taking this. TRUST was officially founded on February 5, 2025. That's less than 11 months ago. 1 month later, in March 2025, they announced a $120 million angel round led by Lanxi Ventures and Chiming Venture Partners. Chinese state media called it the largest angel round in Chinese embodied intelligence industry ever. Then in July 2025, just 4 months after the first round, they closed a $122 million angel plus round led by Meituan's strategic investment arm. That brings their total funding to $242 million in less than 6 months of existence. And honestly, that's crazy. Most startups take years to raise that much money. TARS did it before they even publicly sold their first product. The funding team is a big part of why investors moved so fast. CEO Dr. Chen Yileng was the chief scientist for Intelligent Robotics at Tsinghua University's AI Institute, then CTO and Chief Scientist of the Autonomous Driving System at Huawei's Intelligent Automotive Solution Business Unit. And before that, Chief Machine Vision Engineer at DJI. Chief Scientist Dr. Ding Winzhou is a Huawei's Genius Youth alumnus who worked at Huawei from 2020 to 2023 and is now a tenure-track associate professor at from the university. Chairman Li Zhenyu used to lead Baidu's intelligent driving group and ran their Apollo self-driving platform and Luo Kuaipao robotaxi service. These aren't random founders with no experience. They are the people who built some of China's most advanced AI and robotics systems over the last decade. When you have a team like that, investors pay attention immediately. And the timing couldn't be better. China's embodied intelligence sector is exploding right now. According to industry data, there were 114 investment deals in the first 5 months of 2025 alone, compared to 77 deals in all of 2024. Total funding reached 23.2 billion yuan, which is about 3.2 billion USD. Companies like Unitree Robotics, AgiBot, and AgiBot are all raising hundreds of millions of dollars. Meituan, the Chinese food delivery and tech giant, has invested in at least 5 robotic startups in this year, including TARS. And JD.com, another e-commerce giant, just led funding rounds for 3 more robotics companies, all focused on combining large language models with physical robots. The entire industry is betting that embodied AI, which means AI systems that can move and interact with the physical world, is the next massive wave after chatbots and image generators. What really separates TARS from the competition is the focus on being able to grow big. Most robotics research stays in labs for years. TARS went from funding to live public demo in under a year. They are not talking about future prototypes. They are showing working systems today. Dr. Chen emphasized that their closed-loop system, from data collection to AI training to physical execution, is built to scale. He said it follows the scaling law for AI systems, which is the principle that as you add more data and compute, the model gets much better. That's the same law that made GPT and Claude so powerful. Now TARS is applying it to physical robots. And if it works the same way, we're looking at robots that improve faster than anyone expected. Here is what people in the industry are saying. When the embroidery demo dropped, robotics engineers on social media immediately started comparing it to other humanoid companies. Boston Dynamics has been the gold standard for years, but their robots still struggle with delicate handling. Figure AI, the US-based humanoid startup, raised over $600 million and has shown impressive warehouse work, but nothing close to sub-millimeter embroidery. Tesla's Optimus robot is improving fast, but it's focused on factory assembly, not ultra-fine tasks. And Chinese companies like Unitree and AgiBot are pushing hard, but neither has publicly demonstrated anything at this level of skill with their hands. Some engineers call the demo a watershed movement for humanoid robotics. Others said it proves that the hard part isn't making robots walk or lift heavy objects anymore. The hard part is teaching them to feel, adjust, and handle fragile, fixable materials. And TARS just showed they can do it. Now, in fairness, there are still big questions. We don't know how much hardware costs to build. We don't know if these robots can run for 8 hours shifts without breaking down. We also don't know how fast they can work compared to humans. Embroidery done slowly doesn't help factories that need speed. TARS hasn't released production timelines or pricing either. And they're still hiring strongly, which means the team is growing, not shipping to customers yet. But the fact that they went from zero to live demo in 10 months suggests they are moving faster than most companies in this space. The bigger picture here is what this means for future of work. If robots can do tasks that were considered impossible to automate, then a lot of jobs that seemed safe from automation suddenly aren't. Where harness assembly employs thousands of people globally. Embroidery and textile work supports entire industries in countries like Vietnam, Bangladesh, and China. If TARS can put robots into factories that do this work cheaper, faster, and more reliably than humans, those jobs disappear. And honestly, that's the uncomfortable truth nobody wants to talk about. Robotics companies always frame this as helping humans do more or freeing workers from repetitive tasks. But the reality is, when a robot can do your job, companies replace you. That's just economics. And third is speeding up that timeline. At the same time, this technology could open up entirely new industries. Imagine robots that can do microsurgery, repair delicate electronics, or handle hazardous materials that humans can't touch safely. Imagine robots in disaster zones that can work with rubble, cut through debris, and rescue people trapped in collapsed buildings. Or robots in space assembling satellites, repairing spacecraft, or building habitats on the moon and Mars. All of those tasks need the same kind of skill, ability to adjust, and precision that TERTs just demonstrated. And if their robots can generalize the way they claim, we're looking at a future where physical AI systems work alongside humans in every environment, not just factories. One more thing worth mentioning, TERTs isn't just competing with other robotics companies, they're competing with the entire AI industry's shift toward embodied intelligence. OpenAI, Google DeepMind, and Anthropics are all working on models that can control robots. Figure AI partnered with OpenAI to put GPT-style reasoning into humanoid bodies. NVIDIA is building simulation platforms where robots train in virtual worlds before going to the real world. And China's Moonshot AI just released an open source reasoning model that can chain hundreds of steps together, which is exactly what robots need for long, complex tasks. The race isn't just about who builds the best robot, it's about who can combine the best AI with the best hardware and put it into use at scale first. And right now, TERS is in the lead on at least one piece of that puzzle. That's where we will wrap it up. What I'm most curious about now is how fast TERS can move from demo to putting robots into real use. Can they get these robots into real factories in 2026? Can they keep improving the success rate as they grow production? And can they stay ahead of competitors like Figure AI, Tesla, and other Chinese humanoid companies that are all chasing the same goal? Drop your thoughts below. Make sure you are subscribed, hit that like button, and I will see you in the next one.